Hello, dear students. I welcome you all on behalf of Sri Jayendra Rangzone classes. Today, we are going to start a new chapter, that is wave optics. In this chapter, basically, we are going to study the wave nature of the light. So, let us begin. First of all, let us understand various theories regarding the light. There are many theories to explain the properties of light. Out of many theories, the five major theories we are going to cover here. The first one is Newton's corpuscular theory. According to this theory, the light consists of tiny elastic material particles. So basically, according to Newton's corpuscular theory, the light has particle behavior. These particles are called corpuscles theory, corpuscles particles. These particles enter to our eyes and create sensation of vision by affecting the retina. According to Newton, different colors that we see are due to different shapes and size of these particles. This theory, as it is basically the particle theory, this can explain the reflection and refraction phenomena of light. But there was some problem with this theory. Let us see them one by one. First, according to this, if light consists of matter, that is particles, then continuous emission should decrease the mass of the source of light. Should decrease the mass of the source. But that is not the practical case. The mass source does not change. The second drawback or second thing that it could not explain is, according to this theory, light travels faster in denser medium than rarer medium. According to this theory. Light travels faster in denser medium than rarer medium. The third limitation was the concept of interference, diffraction, polarization cannot be explained because it is basically showing the particle nature. So concepts like interference, diffraction, and polarization could not be explained. The fourth point is it could not explain the partial reflection and partial refraction because it says that light is consisting of particle. So it could not explain the partial reflection and refraction of light at same time. So these are some limitations of Newton's corpuscular theory. That's why it was not accepted by the other scientists. The second theory is Eugene's theory or Eugene's wave theory, we can say. According to this theory, light travels in a form of wave. And for light to propagate, we require a medium such as luminiferous ether medium. It requires medium to propagate called luminiferous ether. And this medium exists all over the universe. According to this theory, different colors are because of different wavelengths of this light wave. This theory could explain the partial reflection and partial refraction, interference, and diffraction phenomena. Partial reflection or refraction, interference, and diffraction phenomena. According to Eugene's theory, light travels faster in rarer medium. and then denser medium. Most of the points included in Eugene's theory are valid in today's modern theory also. But again, there are some drawbacks of this Eugene's theory. So let us see them. As it has explained light as a wave function, it could not explain the rectilinear propagation of light. So, rectilinear propagation could not be explained by this wave theory. Secondly, it talks about the medium luminiferous ether that could not found anywhere. So the medium called luminiferous ether could not be found anywhere. There is no proof of existence of such medium. The next, it could not explain the modern physics concept like photoelectric effect, even though it is able to explain partial reflection, refraction, diffraction, and interference, but it could not explain photoelectric effect. So this was also not completely accepted by the scientist. The next is Maxwell's electromagnetic theory. So let us see the points in Maxwell's theory. First, Maxwell postulated the existence of electromagnetic wave. You do not need to ask for the verification or proof. He postulated the existence of electromagnetic waves, which we simply call EM waves. In this theory, light waves are assumed to be electromagnetic waves. And for the propagation of EM waves, electric field and magnetic field are required. Electric and magnetic fields are required. As we can see here, this is the direction of propagation of light. Light is made up of both electric and magnetic field. As light propagates, both electric and magnetic fields also propagate. The electromagnetic radiation is self-propagating composite of an electric field plus magnetic field. The changing electric field produced changing magnetic field produced. So it is basically self-propagating composite of an electric plus magnetic field. As changing electric field produces changing magnetic field. And changing magnetic field produces changing electric field. So it is self-propagating. This theory could explain many things: the rectilinear propagation, the reflection, refraction, polarization, the interference, the diffraction, etc. Majority concepts can be explained by the Maxwell's electromagnetic theory. But again, there were some limitations to this also. The limitations were, again, it could not explain the modern physics concepts like photoelectric effect. The third theory was Einstein's quantum theory. According to this theory, light propagates in form of energy packets, small energy packets called quanta. Each quantum of light called photon. This quantum is called photon and it has energy E is equals to h nu. Here nu is the frequency of light and h is the Planck's constant. This theory could explain photoelectric effect. As it talks about the discrete energy. But again, there were some limitations to this theory also. It can explain the photoelectric effect, but this could not explain the basic concepts like polarization, interference, diffraction. So basically, it could not explain the concepts that can be explained by wave nature of light. Let us understand the concept of wave front. Here we are going to assume light as a wave. Let's say this is source of light. which emits light wave in all the possible directions. Now, if we draw a surface which connects all the points of different light waves which are at same phase, then this surface is called wave front. So what is wave front? It is the locus of all the points in a medium where all the light waves reach simultaneously from single source, such that they vibrate in same phase. And as they are traveling from same source, they'll vibrate with same frequency and amplitude. Let's say if this is the point source, then these 2 points are at same phase, having same frequency of vibration and same amplitude. The locus of connecting this kind of particles is called wave front. There are multiple types of wavefront based on the shape of that source of light. One is spherical wavefront. Here, the source of light is point source. If this is point source, then surrounding it we will have spherical shape wavefront. The second shape is plane wavefront. The spherical wavefront will appear when this will appear when source is at finite distance. The second type of wavefront is plane wavefront. This occurs or appears when source is at infinite distance. For example, if we take sun, then in the nearby distance, the wavefront is spherical, but as it reaches the infinite distance, the distance between sun and earth is very large. this wavefront will become plane wavefront. The third type of wavefront is cylindrical wavefront. This will happen with the long light source, such as tube light. If this is the light source, cylindrical light source, then surrounding it, the wavefronts would be like this. So in all, we will have wavefront of cylindrical shape. This can happen with extended or linear source at again finite distance. So finally, we can say that we can have three type of wavefronts. One is spherical, one is plane wavefront, and another is cylindrical wavefront. We can have spherical wavefront when we have point source at finite distance. The plane wavefront occurs due to point source at infinite distance. And cylindrical wavefront occurs due to extended source at finite distance. Now, let us understand the classification of wavefronts. This is the point source. Surrounding it, there will be a sphere of light. Part of this sphere is called spherical wavefront. When source is at infinite, any type of source, point source or line source, the wavefront obtained is plane wavefront. And when light source is linear, the wavefront obtained is cylindrical wavefront. Now let us understand the concept of wave normal. As the name suggests, it is the perpendicular drawn at any point to the surface of wavefront, which shows direction of propagation of light. So if this is point source, surrounding it, there is a wave front. If we have drawn any perpendicular line to the wave front, this line is called wave normal, and it will give the direction of propagation of light. So we can define it as the perpendicular drawn at any point to the surface of wavefront which shows the direction of propagation of light. Is called wave normal. So from here, we can note this point that direction of propagation of light is always perpendicular to wave front. What are the types of wave normals? If we have spherical wavefront, in case of point source, this is spherical wavefront. Then these are the normals at wavefronts. So the wave normal is radially outward. These are the wave normals. If we take plane wavefront, so this is plane wavefront. Then these are the direction of propagation. That means these are the wave normals. So they are almost parallel to each other. And same is the case with cylindrical wavefront. Let us understand the Eugene's principle. Consider a point source which emits primary waves in all the directions. It's a point source and it emits primary waves in all the directions. At finite distance, it will give spherical wavefront. At finite distance, it will give spherical wave fronts. According to Eugene, every point on this wave front, acts like a secondary point source. The secondary point source will emit secondary waves, which are effective only in forward directions. If we join the final position of waves, we get secondary wave surfaces. Let us understand this with diagram. This is point source. It emits primary waves. Every point on this primary wave acts as secondary source. Let's say it is S dash. It will individually behave as source of light. So it will also emit the light, but only in forward direction, not in backward direction. If we join the final position of waves, we will get the secondary wave surface. Which are effective only in forward direction. If a common surface of tangency is drawn to the secondary wave surface, we will get the secondary wave front. By joining this all S dash, we will get primary wave front. Now each primary wave front has its own spherical secondary surface. If we draw a surface tangent to all these secondary surfaces, we will get secondary wave front. Let us write it down. This point source behave like a point source, which are effective only in forward direction. If we join the final position of waves, we will get secondary wave surface. And if common surface of tangency is drawn to secondary wave surface, it will act as secondary wave front. Again, Every point on secondary wavefront will act as individual point source. They will emit light in forward direction only. We will draw the third spherical surface, tangent to which will give us the third wavefront, and this process will go on. So, if we summarize this, Eugene's principle, we can say the statement says that each and every point on surface of the wavefront acts as secondary source of light, which emits secondary wavelets. Waves produced by them is called wavelets in all possible direction, but which are effective in forward direction only. And if common surface of tangency is drawn to these secondary wave surfaces, we will get secondary wavefront. So this was about Eugene's principle. This is all for today. Thank you.